Okay, looks like my stuff got off a little bit as I transferred it. Okay, so we're going to, in this section, be using sine, cosine, and tangent to find missing lengths in the sides of a triangle. The first thing you do, here's your steps. You'll start by deciding whether you'll need to use sine, cosine, and tangent. And when we have an example up here, we'll talk about how that works. The next thing you would do is set up the equation. If you're using sine, you would set up, well, sine of the angle is opposite over hypotenuse. If you're using cosine, your equation would be cosine of whatever your angle is equals adjacent over hypotenuse. And finally, if you're using tangent, you'd use tangent of the angle equals opposite over adjacent. And then you solve for the missing value. So here's a real example. They want us to find the length of BC. So let me mark where is BC. Now I can't use the Pythagorean theorem on this because I only know one side of my triangle. For Pythagorean theorem you have to know two. So that tells me, that and the fact they gave me the angle tells me I'm going to have to use trigonometric ratios. The side I'm looking for, I'm going to go ahead and call that X, just so I know what side I'm looking at. So, step one is determine whether you're going to need to use sine, cosine, or tangent. How do you decide that? Well, you look at your angle. Here's my angle. And you say, what two sides do I have? Do I have opposite, adjacent, hypotenuse? Which parts do I have and am I looking for? Well, for this angle, our X is the side touching the angle or the adjacent side. And the 12 that they gave me, notice, is that longest side of my triangle, the hypotenuse. So I say, well, I have adjacent and hypotenuse. Okay, what uses adjacent and hypotenuse? Is that sine, cosine, or tangent? Well, cosine does. Hopefully you looked at your notes and you saw that cosine is equal to the adjacent side over the hypotenuse. So that's how I know to use cosine. I can't use sine because sine would use the opposite side. There's nothing there, and it's not the side I'm looking for. So I'm using cosine here. So then you set up the equation. Cosine of the angle. So cosine of my angle, what's my angle? 57 degrees. Equals the adjacent side. So for this triangle, the side adjacent to my angle was X over the hypotenuse, which was 12. I have set up my equation for cosine using this triangle. The next thing I do is evaluate sine, cosine, or tangent using my calculator. So I take out my calculator and I evaluate this right here. Cosine 57 is just a number. Okay, so I clear out my calculator. I put in my angle 57 and push cosine. Again, make sure you're in degree mode. And I get 0.544639. I'll cut it off there. Okay, 0.544639 is what the cosine of 57 is. So I found that number on my calculator. I would just leave that number in your calculator. For writing purposes, I go ahead and I'm rounding it off. Again, the cosine of 57, which was 0.544639, is equal to X over 12. And I solve this equation. The safest thing to do is to leave that number in your calculator. And as you're solving here, what would I have to do to solve? Well, X is divided by 12, so I do the opposite and multiply by 12. Whatever I do on one side, I have to do on the other. So again, I just left my last number in my calculator so that now I can just go times 12. And I get my answer, 6.535. It wants me to round to the nearest hundredth, which is 2 decimal places. So I would stop here, but that 5 makes me round up to 6.54. And I have my answer. So again, those were my steps. I first looked and I saw I'm looking for the adjacent side. I have the hypotenuse. Cosine is the one that uses adjacent and hypotenuse, so I need to use cosine. Then I set up my equation. Cosine of the angle, our angle is 57, equals adjacent over hypotenuse. I used my calculator to find out what the number for cosine 57 is. then I solved my equation. Okay, here's another example. Let's go through the steps. Here, what do they want? They want the length of PQ. So here is PQ. I'm going to call it my X because that's what I'm looking for. Then I look at my triangle and I say, okay, here is the angle they gave me. This angle right here. I'm going to move that. It's in my way. And looking at that angle, what parts do I have? Well, notice this is the hypotenuse across from my right angle. I have nothing there, and it's not the part I'm looking for. So I'm not dealing with hypotenuse at all. I'm looking for the opposite side, and I have, for that angle, the adjacent side. So step one was to decide, am I using sine, cosine, or tangent? So I would go, okay, well, which of those uses opposite and adjacent? Look in your notes. And if you look in your notes, you'll notice that the tangent of an angle is opposite over the adjacent side. So I know I need to use tangent because I have opposite and adjacent that I'm working with for this 24-degree angle. So now I set up my equation using tangent because that's what I decided I needed to use given my information. We write down tangent of the angle. What's the angle? 24 equals the opposite leg, x, over the adjacent leg, length 32. Next, I'm going to use my calculator to evaluate tangent 24 and find out what number that is. So I put my angle in and then push tangent, 0.44522. Again, I'm just going to leave that number in my calculator so I get the most exact answer possible. For writing reasons, I'm going to go ahead and write down 0.4452. That's my tangent 24 equals x over 32. And now I solve that equation. Okay, so again, I have 0.4452 approximately equals x over 32. How would I solve that? Well, I have x divided by 32, so to get x by itself, I do the opposite and multiply by 32. Whatever I do on one side, I have to do on the other. So again, it comes in very handy that I just left this number in my calculator because now all I have to do is hit times 32. And I get my answer of 14.247. It wants the nearest hundredth, so I stop here. 7 makes my 4 round up to a 5. So I get 14.25. Okay, here's one more example. What is the length of JL? So find JL, the line from J to L. That's my unknown that I'm looking for. What do we have? First step, are you going to use sine, cosine, or tangent? Well, here's the angle they want me to work with. What do I have? Okay, well, where's the hypotenuse? Hypotenuse is across from the right angle. Here's my hypotenuse, so I have the hypotenuse. Here's the adjacent side, the side touching the angle, and x is my opposite side. It's the side across the triangle from my angle that I have. What uses opposite and hypotenuse? Is it sine, cosine, or tangent? Hopefully you have those written in your notes so they're easy to find. And you're able to say, well, from my notes, I know that the sine of an angle is the opposite side, the opposite leg over the hypotenuse. So I will be using sine. I set up my equation. Sine of the angle. What angle did I have? A 48-degree angle. Equals the opposite side, which was length x, over the hypotenuse, which was length 18.4. Next, I use my calculator to find the sine of 48. Okay, so we put in our angle 48 and push the sine button. I get about 0.7431. Again, just leave that number in your calculator for later purposes. So So I have now the sine of 48 was 0.7431. So now I have 0.7431 equals x over 18.4. And I have one last step that I need to take to solve this. It's x divided by 18.4. So to solve for x, I would have to multiply both sides by 18.4. And again, that's where it comes in handy that I just left that sine 48 in my calculator, because now all I have to do, it's still in there, all I have to do is times 18.4. And I get my answer. My answer is 13.67. I want to the hundredth, which is 2 places after, and that 3 is smaller than 5, so I just stay at 0.67. My answer is 13.67.